Hello everyone. In this video, we are going to use Jamovi in order to help us create confidence intervals for proportions. Okay, so let's look at our scenario. So here it says that Dax is out trying to do a study on the proportion of individuals in Casper who went hunting this season. He randomly selected 154 people from the community and had them report whether or not they hunted this year. He decides to make a confidence interval to approximate the proportion of people hunting this season. He wants to have a 92.5% confidence. Okay, and let's go ahead and get our data in. So let's just go ahead and grab the data. Let's copy it in. Let's go over to Jamovi, go to data, paste it, and then let's do just a little bit of altering here. I'm just going to name this hunt. And just for convenience, I'm going to change my levels to have yes at the top and no at the bottom. All right, so now that I've got my data all set up, now let's go ahead and take a look at these questions. So these are general, like what's our population, what's the statistic, what's the variable. Let's go through and do all these. So let's first of all look at the population. So the population that Dax is trying to make some sort of conclusion about is all people living in Casper. And so since that's a population, then now let's go take a look at what the sample is. So the sample is going to be the 154 Casperites who's selected to respond whether or not they went hunting this season. Let's make that VD. All right, so now that we have the population and the sample, let's now go talk about the parameter and the statistic. So the parameter and the statistic, remember, parameter is some truth about the population, statistic is some truth about the sample. So let's go ahead and we'll look at the proportion of people who went hunting of all of Casper. So that's going to be the parameter because it's some truth, some proportion about the entire population. Now, if we look at the statistic, it's going to be the proportion of the 154 individuals or the truth about the sample. So that's going to be our statistic B. Now we're just left with the data and the variable. And so the data is just the list of these responses. So that's going to be E. And just the answer of whether or not a single respondent from the sample went hunting this season. That is going to be our variable, which is going to be C. Okay, scrolling on down. So now he says that Dax knows that he can only use the normal approximation here in certain circumstances. Is he good to proceed with calculations? All right, so this is going back to this, like, do we have a big enough sample in order to support whether or not we can actually use the normal distribution? And we need the normal distribution in order to calculate out these confidence intervals. So let's just go ahead and do a quick analysis. Let's just do an exploration. Let's look at our descriptives. Let's grab hunt. Let's bring it over. And what we're going to do is we're going to just do a basic frequency table. Okay, so and now it gives us some counts. And what we're looking when we are doing confidence intervals is the number of yeses and the number of no's. So remember, the cutoff was 15. We need at least 15 successes and 15 failures before we can use this normal approximation with proportions. So yes, we've got at least 15 with yeses and 15 with no's. So that's going to be a yes. Okay, so moving on along, the best point estimate of the true proportion is just going to be our sample proportion of the number of people who went hunting. So that would be the yeses that they went hunting. So this is the 48 out of that 154, and it's 31%. And we remember when we type it into MyOpenMath, we want it in decimal form. So this 31.168 or whatever, and that's what we have right here. Okay, so now we're looking for this confidence interval for the proportion of hunters. All right, so in order to do this, we are going to go to R real quick. We're going to go to the R editor. And before we get going, we're going to click on the gear and say we want to show code and output when we run stuff. Okay, and our equation that we're actually using, I'll type it up here first, is going to be confidence interval equals our sample proportion, P, and then it's going to be plus or minus, and now we're going to type out our Z critical multiplied by our standard error. All right, so that is going to give us our confidence interval. And really what we're going to do is because R does one at a time, we're going to do a confidence interval lower, and we'll just have that be a minus. And let's copy this. We'll paste it, and we'll have a confidence interval upper, which is just a plus. Okay, so we need to figure out how do we get our P, how do we get our Z critical, how do we get our standard error. We need to figure out all of these. All right, so up above these, let's get just our basic information that we have. So let's start off with N. Our sample size is 154, and we got that from right over here when we pasted our data in. Okay, and then I'm just going to say the number of yeses, or I'll just say Y, we'll do yes, is equal to 48. We got that down from our frequency table. All right, now our sample proportion P is going to equal yes divided by our sample size N. And that will give us our P. We can just type out P right here if we want to see it, and it should be very similar to this 31. Let's run this real quick. Oh, sorry. It's getting angry at my Z-crit. Let's go ahead and calculate out our Z-crit real quick. Or here, I'm just going to highlight that and see if I can just run it a little bit. Oh, there it is. Sorry. Here it is. It's 3117 is our sample proportion. Now, remember in the RJ editor, we have to do this little extra bit of code in order to get more decimal places. So all I'm going to do is I'm going to do options, digits, equals, we'll do like 8. That'll be good. And if I run that again, it's still going to have an error for me, but now I've got more decimal places for my proportion down here. Okay, so we need a couple more things. We need our standard error. Let's get our standard error. And the standard error is just going to be equal to the square root of, we'll do P times 1 minus P divided by N. That gives us our standard error. And now we just need our Z-crit. Okay, in order to do our Z-critical, we actually need just a little bit of extra information. We need to know our alpha level that we are dealing with, and then we can go grab our Z-critical. So let's just put in alpha right here, and let's see if we can figure out what it is. So we've got to go back up to our scenario, and we are given our confidence level. So let's actually start off with our confidence level. Confidence level, we'll just type that CL equals 0.09225. 8, 5. There we go. Alpha is just the complement of the confidence level. And so I'm just going to do alpha, type it out like that. And let's run this again. And it gives me my alpha of 0.775. Okay, great. Now, when I am doing a two-tailed confidence interval like this, I really need to know what alpha divided by 2 is. Alpha divided by 2 is going to be very helpful for me, so I'm going to type out alpha divided by 2. Now, we are doing this because we need to put our alpha, since we're doing two tails, we're going to have an upper and a lower bound, and we're going to put our errors on both the upper and the lower ends. So that's why we're doing this alpha divided by 2. So let's run this real quick. We get alpha divided by 2 is 0.38, or 0.03875. Okay, excellent. Now we've got everything that we need in order to actually calculate out our Z-critical. So in order to calculate out our Z-critical, we're going to go back and use a tool that we've been using before, and we're going to use distraction again. We're going to go to our normal distribution. And in our normal distribution, we are going to leave our mean and our standard deviation alone. When we calculate Z-criticals, we're going to leave those alone. Now I'm going to go compute a quantile. And the quantile that I'm going to use is I'm going to use this alpha divided by 2. And I'm going to do 0.03875. I'm going to use that alpha divided by 2. And I need to make sure that I'm on the cumulative quantiles. Okay, And I just need the absolute value of this number, because when we do two-tailed, we're actually going to go from this side here and this side over here. So we could do it like that, or let me show you another way that we can get to get this value, is we can do, let's see, we can use just the confidence level and do a central interval quantiles. Let me just show you that real quick because that's handy too. We'll do central interval quantile, and we will do this as 0.9225. And look, it gives us this same number, this 1.765. And this is nice graphically because it kind of shows us what this two-tailed interval is doing. We're going to do an interval from our proportion, that our sample proportion. We're going to go up and down a certain level to give us an interval. And we're going to cut off these tails. And the amount that we're going to cut off is our alpha level of 0.0775. Okay, so let's keep this 1.765 is our z critical. Let's go back into here. Let's type out z crit equals 1. Forgot it already. 765. Okay, so there is our z critical, and let's go ahead and run this whole thing real quick. Oh, and then I actually want to see what my confidence level is. So if I want to do that, I just have to type it out again. Confidence interval lower, confidence interval upper, and now let's run this. Okay, so now I have an upper and a lower bound. I have this lower bound of 0.2458 and this upper bound of 0.3775. And if we go down and we look at our answers, we have 0.245 when we round to 4, and we've got 0.3775. Okay, now if you notice, I actually have two different answers here that I will accept. And that's because Jamovi also has a way for us to just ask it to give us a confidence interval. And it does a slightly different calculation for how it does the proportions. I'm not going to go into the nuts and bolts of it, but I'm just going to say that both of these are correct. If we do it by hand, that is a fine way to do it. And the other way that we can do it is we can do this ESCI. So if we click on ESCI, we come down to estimate proportion. What we can now do is we can say, click on to hunt, click over to variable, and we can just say, okay, give us a confidence interval of 0.9225. Oh, sorry. We've got to get rid of point. Sorry, this one does want us in percentage for 92.25. Hit enter. And here it gives us a confidence interval for both the yes and the no. So it's kind of handy here. We can do either direction if we want. But if we want to see what the confidence interval for the yes is, there it is for both our lower and our upper. And as we've been doing these, this is a two-tailed test because we've thrown alpha to two sides. So we're going to say that that is two-tailed. Next, we can select an appropriate conclusion about our confidence interval. And we can say that we are 92% confident that the true proportion of Casparites who went hunting this season is somewhere between 0.25 and 0.38. The other ones are problematic because, so this one is like confident about the sample proportion, and we're not making a conclusion about the sample, we're making a conclusion about the true proportion. And the problem with these ones over here is we're using this word chance, is we're saying that there's a probability that the true proportion is moving, or the probability that the sample proportion is changing. And that's just not a correct way to say this. So here we are, this one right. Okay, so this next one, or these next two that we're going to do, we're actually going to kind of do them together. So these next two, let's read what the questions are. So it says, suppose instead we wanted the confidence interval for at least the true proportion of hunters is. Okay, so this is saying, hey, we want to see at least so many people in Casper went hunting. Or suppose we wanted to say, we want to be 92% confident or whatever that no more than so many hunters went, or the proportion of people in Casper who went hunting. So both of these are what we called one-tailed confidence intervals. So that one's going to be one-tailed. This guy is both going to be one-tailed, but they're one-tailed in different directions. Okay, so for up here, when we see that we have the confidence for at least, let me try to get this to show you an example of what this is going to look like. So if we say at least, we want to put all of the interval on one side because we want to be from this lower portion and all the way higher. So if I did like 0.05 real quick, and we did a cumulative quantile, this is the at least from this portion all the way above. I want to be 92% confident that we are at least some value. Now, if I wanted to go the other way, like I can do 0.95, and I want to say no more. So those are one-tailed because I'm putting all of my error or all of this alpha off to one side. Okay, so when we do this, we need to change up our equation just a little bit. So let's go back to our R editor. We're going to click on this guy. And so far we've done this all for two-tailed. And so I'm just going to put up here, if you type out a pound symbol, and then you can just type in some comments. This is for two-tailed. And if we go down below, I'm going to say, oops, this is for one-tailed. Okay, so our sample size and our sample proportion, all of that stays the same. The standard error, heck, that even stays the same. The only thing really that changes is a little bit of our confidence intervals. So now instead of being a upper and a lower, now what we are saying is that we are just looking for the critical spot on one end. And then the other side goes to either 0 or to 1, because that's the maximum and minimum that a proportion can be. Okay, so let's look at this. We'll call this a lower, or we'll do one-tailed lower bound, and we'll call this is when we say like at least. And the equation that we're working with is actually this guy right here, confidence, where we are just subtracting. But this Z critical is just a little bit different. So this Z critical, let's do a little bit note, Z crit, where alpha we divide by 2. And then here we're going to do a new Z critical. We'll type out Z crit with alpha. Okay, so this is because instead of dividing our alpha and throwing it to two sides, we're going to put it all onto one side. So now we need to know exactly what our alpha is. And when we looked at our alpha, it was 0.0775. All right, so let's go back to our normal distribution. And I'm going to put 0.0775. And I get this new Z score right here, this 1.442. I'm going to grab this 1.442 and I'm going to put it in for my new Z critical. Let's go back to, our editor. So my new Z critical, equal to 1.442. And just double check that, make sure that we got that right. Yep, 1.442. Okay, so now that's going to be our lower bound, and our confidence interval upper is just going to be equal to 1 because we're going to go to like our maximum value. Now, if we were dealing with means, remember we'd go either to positive infinity or negative infinity, but with proportions, we can only be as high as 1 or as low as 0. Okay, and then if we do a one-tailed one-tailed, let's say upper bound, we'd say like no more. What we actually do is we do the exact same thing, except we're just using the plus side. And the lower is equal to 0. But our z critical is actually going to be identical from the one-tailed lower. It's just going from the other side. So if we look at this, we'll come back in here, and instead of doing 0.0775, here what we're going to do is like, we do 92.25. That's just throwing it to this upper end now, but it's still 1.422. We're just kind of mirroring it about the middle of this bell curve. Okay, so back to here. Let's go ahead and run these guys real quick. Run this whole thing. Add in a few extra pieces. Oh, and we forgot to type out our confidence interval lower, confidence interval upper, confidence interval lower, and confidence interval upper. All right, let's run this one more time. Okay, so now we've got our bound, or our kind of one-tailed confidence intervals. Go look and see if we got this first one right. So this is for the one-tailed, for the at least, and this is where we did for the at least. So we got 0.2578 all the way to 1. And we got 258 and to 1. Now there is a little bit of a rounding error, but it's totally fine. It's just because of what our z critical was rounded to when we do our calculations. Oh, wait. Give me just a second. Oh, no. Oh, I had a small error here. It's supposed to be 422. 422. There we go. I made a mistake when I was typing in our z critical. Let's run this again. There we go. 2586, 2586 into 1. And let's look down here and see if we did it right. From 0 to 3.66. And let's see if I did slight. Oh, no, yeah, 3.647. 3.647. Okay, so this other one is if we do this when we are using, Jamovi to estimate it for us. There's a way that we can do this. So now if we use a Jamovi estimation, we actually have to do something a little bit sneaky, and I'll show you what's going to happen. So let's look at, we'll call this Jamovi for one-tailed confidence intervals. What we need to do is we need to actually double alpha. We need to take alpha times 2. And that's the alpha that we're going to use in our estimated proportion. Let me show you. So let's go ahead and run that alpha squared, or this 2 times alpha. Let's run that. Oops, sorry, wrong thing. There you go. So now we've got alpha times 2 is 0.155. All right, so when we go up to our ESCI, and we come down to these estimated the proportions, we can click on this guy. We can bring the hunt over. And we need to know this confidence level. And so the confidence level that we want is actually going to be 84.5, which is the 1 minus our alpha level, that 15.5, which is going to be this 84.5. And what it's going to give you here is, oh, this is a little strange. hold on a second. We have a z somewhere kicking around, and we want that z out. There's no reason for that z to be in there. Let's go look at our data. Yep, it looks like I accidentally typed in some z's in here. Let's go make sure what our first number was. Oops, wrong one. First one was a no. So we need to make sure that that first one actually says, there we go. Okay, so now what we said is we have both this lower and this upper, and if we look at it, what we actually were given to us is both the lower and the upper at the same time. So here is that lower 0.261, and the upper 0.3669, 0.3669. Right, so graphically what has happened, let's go look at our normal distribution just so that I can kind of show it to you. What we basically did is we said compute the quantiles for 0.855, and we want this for central. What it did is it gave us our cut point from the bottom and the cut point from the top. And what you have to remember to do is you remember that when you're doing a one-tailed, let's say we're doing a lowered one-tailed, you grab this lower point and you go all the way to 1. And then for the upper, you can grab this upper point and go all the way down to the left. So you can use Jamovi to automatically give you those the cutoff points for an upper and lower bound one-tailed confidence interval. But in order to do it, you have to double your alpha and put it in so that it'll give you the upper and lower correctly. Right here, like we did. Okay. So that is how you go through and do those. And then once you get your confidence intervals, we want to go through and actually select these correct ones. And it follows the exact same format as before. We're still looking for 92.25% confident that the true proportions is at least so much. So we can click that guy. And we can go through 92.25% chance that the true proportion of capsular was no more than 0.36. So that is how you go through, and you can use Jamovi in order to help you calculate these. So we can do this, once again, just a reminder, one of two ways. So our first way that we kind of looked at and did it is we did it by hand. Now, these calculations, you don't have to use this editor. You could also use Excel or some other tool, but this is a way that you can kind of type out and keep track of all of your variables that you're using. Or we can go in and we can use this ESCI and estimating the proportions, and we can use it to actually calculate our confidence intervals as well. Now, just remember that those two answers are going to be very close, but they do calculate them out slightly differently. But when you type it into MyOpenMath, it will accept either answer as correct. Anyhow, good luck on doing your confidence intervals with proportions on your own.